Welcome to Algebra 2, Semester 1, Unit 6, Section 5.8. In this section, we're simply pulling everything that we've done together. We know that the zeros are the k value that equals a 0. The factors, x minus k. And then the solution, k is a solution if f of x equals 0 when we plug it in, or if there's f of x, the remainder being 0. The x-intercept, if k is a real number, k is the x-intercept at k0 of the graph. Let's get over and actually be doing some of this. So turn to the next page in this packet. And we're given a graph. This is kind of fun. You'll really see how much you've learned about what these different things mean. If you've been in class doing the activities with us, then that really helps. First thing we look at here is that this is a cubic function because this is to the first, so that causes an x to the first. This is to the second, so the highest degree would be x to the second coming out of that. When you multiply those, that becomes an x cubed. Remember, on an x cubed, when it's a positive function, the end behavior is as f of x approaches infinity, that x approaches infinity. And likewise, when it approaches negative infinity, x approaches negative infinity. So we see the end behaviors doing this. Now we can look up here and look at the zeros. This one occurs once, so we know it actually crosses at x equals negative 3. Remember, you set it to 0. So it crosses right here. Now, x minus 2, when we set that to 0, would be x equals positive 2. But do you notice how there's two of these? Because there's two, because there's an even number, that means it doesn't cross at 2, it goes tangent to the line. Knowing that the end behavior is going this way and this way, that tells us that there's something happening here. Okay? So the easiest thing is to plug in a few values. So if we plug in, let's say a negative 2, and we just simply work it out in the equation, negative 2 plus 3 would be 1. Negative 2 and negative 2 is 4 squared. That would be a positive 4. So, I'm sorry, negative 2 and negative 2 is negative 4. Squared would be a positive 16. That was times a 1. And then we take a sixth of it. Well, 16 over 6 equals, 6 would go in there twice, that's 12 with 4 left over, 2 and 4, 6. So 2 2/3 basically at that negative 2. So negative 2, 2 2/3, about right there. Now we plug in negative 1. Negative 1 plus 3 would be 2. Negative 1 minus 2 is 3. Squared would be 9. That equals 18. We take a sixth of 18, and that would be 3. So at negative 1, we're up here at 3. If we plug in 0, 0 plus 3 is 3. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 times 3 is 12. Sixth of that would be 2. So we begin to see our behavior on that graph. Okay? And the interesting thing here is the turning points. These points at which these graphs turn like this. A polynomial function will have at most one less turning point point, then it's degree. So how that was a third degree, at most it would have two turning points. Okay? And we have a turning point here and a turning point there. Okay? A polynomial will have exactly one less turning point than it has x-intercepts. Okay? So here, remember we've got an x-intercept here, and we have 2 here because of the tangent. So we have 3 basically. So we've got the 2 turning points. Here's a couple vocab terms that you need to be aware of. Local maximum is any point higher than any nearby points. So that would be a local maximum. Local minimum is any point lower than all nearby points. So these are relative to what's around, or local to what's around. Okay? Next page. If you notice at the top of the next page, it says to use a graphing calculator. I can't be assured that all of you have graphing calculators at home, so please come into class ready to do this in small groups with a graphing calculator. And that brings us to the end of that section. Thank you for watching. We'll see you tomorrow in class.